In this video, the following will be discussed: a quick overview over Visum, how to build your network on Visum using nodes, links, and zones, calculate the Skim Matrix, and finally trip assignment to your network.
Welcome everyone. In this tutorial we are going to start with the basic layout of the Visum software. I'm using here Visum version 15, which is a licensed version, but for sure you can download a student version, but take care that the student version needs that you save every 45 minutes, and the program should be restarted again each or every 45 minutes. Okay, so we're going to begin here with the layout of the software Visum. There are slight differences between each version and another. But there are some basic things that do not change from one version to another. So you have here the network list, which you have all the needed items that are needed to use or draw your network and evaluate it. We have nodes, links. We are going to deal in this video with the nodes, with the links, with the connectors, and with the background images, which is here. First of all, you should know that you have two main icons here. The first one, which is the plus icon, which allows you to add any item to your network or to your model. And the second is the edit mode. So when I choose, for example, a node and select the insert mode, and when I click like that, a new node will be created. However, if I need to do any changes to this node, I shall select nodes, then select the edit mode here and do my edits like this. Okay, back to our network, which is the network editor here. The second thing you need to take care of that you have here the background image, which is the default background image of the program, which allows you to have the world map like this. So if you are going to deal, for example, with some network here, you are going to zoom to it, for example, for this one, and then start drawing on this one. But in this video, we are going to learn how to draw our network and build our model using an external background image. For example, this very simple town. This very simple town consists of some zones. You can see like here 1, 2, 3, 4, 5, 6, 7, 8 zones, and the road networks are like this. The blue one is the major arterial road, the red ones are the minor arterials, green color indicate the collector roads, and there are some local roads here in each zone, but they are not drawn in here. For sure, if you are having a real network like this, so you are going to have the same thing. For example, you have two major roads or two major arterial roads here. You have minor arterials like this one and this one, and some collector roads like this and like this, and some local roads inside like this one. Okay, so first of all, the first thing you have to do is that you know the road hierarchy that you have and the plan layout that you have for your town or city or whatever. For the student version, by the way, the student version allows you to divide up to 30 zones only, but in this license, we have a license here, the version which I'm using now. This version allows you to build your model using more and more zones, more than 30 zones. Another important thing that you should know that each zone should be homogeneous in its characteristics. For example, if we are going to have a real life example like this, you should know that dividing the zones depend on their characteristics and to be homogeneous in their characteristics. For example, if I have a commercial area like in this one, so this I can consider this one as a zone. But if I have this area is residential, this area is commercial, so it's better to divide each zone separately even if there is no road between them. So I'm going to have this zone like zone number 1 and another zone here which is commercial, which to be zone number 2. Another thing that if you have a residential zone like this and another residential zone, or this is I think this is I have a stadium here and there are some parks here, so they are recreational zones or zones which people go for example recreational trips and on their weekends and like that, but I have a major road between them. So even if I have a homogeneous zone here and this zone is homogeneous in its characteristics like this one, but it is better to divide them because there is a road between them. This road could be a railway road, this could be a railway, a roadway, or even a river, a mountain, like that. So I have a physical separation between these two zones. So even if the characteristics of the two zones are homogeneous, but it is better to divide this as zone number 1 and this zone number 2 because there is a physical separation between these two zones, whether it is a road, a railway, or whatever, or a natural like lake or something like that. Okay, back to our topic, which is this hypothetical network or this hypothetical town. This town is divided to 8 zones and we know the road hierarchy for it. We are going to assume that because we do not know, this is not something real, so we are going to assume that the major roadway is 5 lanes in each direction. The minor arterials are 4 lanes per direction, while the collectors are 3 lanes per direction. What we are aiming to do is that we are going to evaluate this network according to the land use and to the trips on these roads. So another data we need are the demand matrix, which are like this. For example, I have from zone number 1 to zone number 2 in the peak hour there are 1020 PCU or passenger car units per hour from are moving from zone 1 to zone number 2. The same thing from zone number 1 to zone number 3, we are having 1800 passenger cars per hour, and this is the peak hour volumes. And for sure you can get this matrix through the attraction and production that you calculated before between the different zones. So the input data we have are 2 things till now. The first thing is the plan layout of the town, which is divided to 1, 2, 3, 4, 5, 6, 7, 8 zones. And the second thing is the demand matrix in passenger car units per hour from each zone to any of the other zones. Our goal is to define or to calculate 2 main things in this video. The first thing is we are going to calculate the Skim matrix or the time matrix, which is the free flow time, the free traveling time between each zone and another, and the free time or the free traveling time is the time that you take to move from one zone to another zone when the network is all empty. For example, if the network is all empty, no cars or no vehicles on this network, and you are going to move from zone number 1 to zone number 2, so you are going to consume, for example, 5 minutes. So this is the free travel time from zone number 1 to zone number 8, for example, and the same thing from 1 to 2, zone 1 to 3, and etc. The second thing that we are going to calculate is the trip assignment. We are going to do the trip assignment on this network, and the trip assignment is going to be assigned to this network in order to know the V over C, or the volume over capacity of each road. And if the V over C is a huge number, this will give us a bad level of service. And when we have a bad level of service, we are going to recommend that the capacity of this road, for example, will be should be higher, or the number of lanes, for example, should be increased, or we are going to recommend that another road should be added here, so that the zones are split and the traffic volumes are not concentrated on one road, or any other recommendations that will improve the level of service on the network. So in this video, we are going to do two things. The first thing is calculating the Skim matrix, or the travel time matrix, and the second thing is evaluating this network through the V over C ratio. Okay, so this is the first part of the video. In the second part, we are going to assign this network to the Visum, and then we are going to proceed in drawing this network and building our model, then calculating the matrices. In this part of the video, we're going to build our town model and then calculate the Skim matrix. Okay, first of all, we are having our hypothetical network here. So we do not need here to open the map, so we're going to close the map. The second thing, we are going to insert our image, which is a PNG file or JPG file like this. And this file, or this image, should be scaled. So we have two dimensions here, which is 273 meters and 239 meters. For sure, you should make sure that the units you are using in your program is correct, which is the metric system. So we are going to go to edit menu and user preferences, and here in the network we can see that we are going to deal with the metric system, which is kilometers or meters and kilometer per hour, and the direction of traffic is right-hand traffic, which is not the English system or the British system, which is left-hand. Okay, so we are going to go here to backgrounds. We are going to select it, then insert mode, which is the plus sign, and click anywhere here. We are going to insert a graphics file, press OK, then use the path for the image we have, which is here. We are going to copy we are going to copy the path, Control C, and going to Visum again, Control V, open, and select our PNG file and click open. Okay, if you can't see it, you just have to click on this icon, which is display the entire network, and you're going to see your network here. Okay, the background is inserted, but I think the dimensions are not correct. If you're going to check this and measure this, for example, it is 27 or 29 meters, and this is not correct. we should scale this image so that we are going to have the real dimensions. So you're going to select backgrounds again and select the edit and double click on it. Here you can find the scale button, and you are going to select from this end. Sorry, you're going to do it again. Scale, just click and keep pressing the left button on your mouse and measure this one and define this as 273 meters. Okay, so I'm going to close it again, display the entire network. If you are going to measure it again from this point to this point, yes, I think it is approximately correct. For double check, we can measure another distance, for example this one. Okay, this is 238 meters or 238.8. Okay, so we are nearly correct, and this is acceptable for our macro simulation. This is a macro simulation, not a micro simulation, so these small errors are not effective or won't do any difference to our results. Okay, so we inserted our network in here. The second thing, we are going to define the nodes. The nodes are the points of intersections between the roads. So we are going to have here a node in every intersection. But for this one, this is not a node. This is a continuous road going like this. So we are going to the nodes in here and press the plus, and we are going to add nodes. This is the first node. Okay, second node. Okay, and define all nodes that you have in your network. So now I have added all the nodes I have in the network. We can change the display for it. I am going to skip the display, and these things we can do it in a later video, but for a quick guide for you, anything related to the display of anything like the colors and these things, you can do it from the graphic parameters. So we are going to go to the nodes, right click on it and choose edit graphic parameters, and from in here you can change, for example, the color. We can change it from a circle to a square, for example. You can change its size to be 2, for example, and these things. Okay, and I don't know, sorry, edit graphic parameters. Okay, well, I'm going to change the color. And the form to be, for example, a triangle. Okay, so the nodes changed its colors and its size, and symbol changed from a circle to a triangle. And you can try by yourself editing another graphic parameters in the form which you need to represent your network. Okay, back again to our network. So all the nodes, I have forgot to add a node here, so node plus and add another node here. Okay, by the way, if you are needing to see all the list of your nodes, you can right click on it and see the list. So you have 13 nodes in here, and the coordinates of each node, x and y. So you can see here your list nodes. To be back again to your network editor, you choose network editor from here, and you can close this list if you do not need it. This is the junction portion. Okay, so we define the nodes now, and you are going to draw the links which are acting like the roads. So okay, but firstly you should define the roads hierarchy, which we talked about in part 1. The roads hierarchy should be defined first. So you're going to links, right click and list link types. So I'm going to define the link types I have in my network. you can see in the student version, I think in the student version this list is empty, but you can add whatever you want from the link types. So I'm going here to define my link types. Number 0 is the major arterial, and it is 5 lanes in each direction. Take care that this is the number of lanes in each direction, and it is used by all the modes, buses and cars and so on. And the capacity, if you're going to assume that the capacity of one lane, you should search for this, because it differs from one country to another and according to different researches. But if you are going to assume that the capacity of the one lane is 1,000 vehicles per hour, so 5 lanes will be 5,000 vehicles per hour. And the free flow speed on it, this is the major arterial, so I think it is expected to have 80 kilometers per hour. The second one is the minor arterials, and it is 4 lanes per direction, and accordingly will be 4,000. And the free flow speed on it is 60, for example. And the third link type is the collector roads, which are smaller, and they are having 3 lanes in each direction, 3,000 vehicles per hour, and I can keep it as 50 kilometers per hour. So I defined the 3 link types which I have in my network, which are this one. The blue one is the major arterial, the red ones are the minor arterials, and the collectors are in green color. Okay, back to our network. So I'm going to close this one and back to network editor. Okay, I'm going to draw our links. Firstly, click links plus icon, and I'm going, for example, to define the collector first. So I'm going to draw from this link, from this node to this node. It's going to ask me which type of this. I'm in the collector. This collector is 2 directions, which is a two-way street or road. It serves from this direction to this direction. If you are going to have a one-way street, so you are going to close the opposite direction. But in this case, you are going to have all the roads are serving as two-way directional roads. So I'm going to choose this one, which is collector, and okay. The same thing, I'm going to define all the collectors, but I'm going to give you a very simple hint, which you are going to use in the next part. This hint is that it's better to add a just small king in each link you have, at least one king, which is a virtual node like this. So, and this is a collector also. I mean, you don't join 2 nodes directly, but just do a small node like this in the middle of it. If you are going to select it, you are going to see, okay, you do not see it here, but it exists in here, and you are going to know why in the next part. Or you can do it directly, then add some nodes in the middle, for example, like this. I think this is better, to add a node like this and a node like this. So I'm going to delete this again for a while and do it back and add some nodes in the middle of each link, and you are going to know why I did this just a few moments later. Okay, we can have a node here. Okay, the reason I did this, because when I later will add the connectors, which are the local streets in each zone, they are going to intersect each link in a node, in an intersection. We're not going to join the local streets or the connectors. The connectors here act as the local streets, which are going to add later. We are going to intersect them not in the major junction here, but in a virtual junction in the middle of each link. So I'm going to we already defined, I think, yeah, list link types. Okay, I defined this. Okay, so I'm going to back again to the network editor and add my links again. So from this one to this one, it is a collector. The same thing here. This is a collector, and you're going to complete all your network in the same manner. Okay, for example, if you are going to add here the arterial here, this is a minor arterial, so do not forget to change it to minor arterial. Okay, and from this one to this one, this is a minor arterial, and you're going to complete all your network. If you need to change something, for example, if you did someone wrong, for example, if I added a link like this and I by mistake chose the wrong type for it, and I'm going to change it or edit it, so I'm going to go to links, edit mode, and click on it. Then when I click it, here we can change its type, but take care that when I chose it in the first from the beginning as a minor arterial, it took the free flow speed of the minor arterial, it took its number of lanes, and it took its capacity. But when I change it to its correct type, which is collector, these things are not modified. So I'm going to modify it manually, which is 50 km/h. The lanes are 3, and these are 3000. So it is better to delete it, okay, because you can have something wrong in here. Okay, this is the collector again, but it's better to delete it, so it is automatically assigned to its characteristics. So I'm going to delete it and add it again in this by this way, and choose it again correctly, collector. Okay, so if I go to edit and choose it, I will find these characteristics are automatically defined by the type of the link in here, so you do not forget anything. Okay, I'm going to complete my network and be back to you again. Okay, so now I added all the links I need, and now I do not need the background image because I drew my network. We can turn off the layer of the background from in here, so we can see only the nodes and the links. And if you forgot something, you can open the background image again like this from clicking this icon and draw your link and turn it off again. Okay, for easiness, we are going to change the colors to be more clear. So I'm going to links here, right click, graphic parameters, and the display. And here we have a classified display, and we'll add 3 because we have 3 types of links. The first one is link number 0, which is the major collector, and I'm going to have the colors the same as the image for our as you like. So I'm going to choose here 0 and give it a width, for example, 0.8. Then when it is 1 equal to 1, it is the minor arterials which have the red color, and for example I'm going to give it 0.5 width, and more than 1, which is the collectors. I'm going to change its color to green and make it 0.4, for example, and click OK. So here we see that the colors changed. I think there is something not correct. Links, edit. No, this is a collector. So link types, we have 0, 1, and 2. Okay, 0, 1, and 2. Okay, back again to the network editor. Oh yeah, you have to change this one, the upper limit. So this upper limit is 1, and this upper limit is 2. No, I think see what happens. Okay, so now it is correctly displayed. We have this in blue color, this in red color, and these collectors in green color. And you can add a legend if you are going to print this, for example. So you're going to add a legend from here. You're going to draw a legend, check this box, and we do not need legend for these things. We are going to have a legend for links only, and you can add it if it is not existing here. So you can choose it from in here and press this arrow and click OK. So we are going to have here this link legend here on the right corner. Of course, you can change it to here legend name, which exists in here on the right upper side. You can make it like this: major arterial, minor arterial, and this is the collectors. Okay, so the names are changed in here in the legend. Okay, so this is the road networks well displayed. So we are going now to define the zones. The next step is defining the zone. So we are going to choose the zone in here and click plus. The first zone, it asks for the centroid. Okay, the centroid, if you do not have enough data, like this case, so we are going to put the centroid approximately in the CG, or the centroid of the geometrical shape. For example, we have here a shape approximately, this is a square, so the centroid will be approximately here in the middle, and this is zone number 1. We'll say OK, and you are going to define the zone boundaries, for example, in here from this, and you are going to move when the arrow points to the centroid. So this is not correct. You are going to move like this. In our zones, like this. So this is zone number 1. We're going to add the second zone, the same thing. This is, for example, the centroid. Zone number 2, OK. And you're going to click in here and take care that you click on the end exactly of zone of the adjacent zone, which is zone number 1, and like this. Okay, and close your zone. This is zone number 2. Zone number 3, the same thing is going to be repeated for 8 times for the 8 zones we have. Okay, so now I defined the 8 zones I have in my town. Now, for sure, you can display it on and off from this icon as well. The same thing for all the items you have. Okay. The last one thing is to define the connectors, which are the local roads. Okay, the local roads are assuming to allow the vehicles to move from the centroid of each zone to the main network you have. For example, I have this network or this zone number 1, and it is surrounded by some links and the nodes, which are the intersections of the road. Okay, so the connectors are like the sidewalks and the local streets, which are making the people reach the main network from their zone. For example, if there is here 2 schools and 2 shops, for example, so we're assuming this point is the point which is generates the trips from this zone, and this zone is connected to the network to this node. So I'm going to select the connectors in here and select the plus and choose from the node, from the centroid of the zone to this. Okay, and it is moving from the centroid to the intersection, and this is why I defined a node in here. I defined a node in here because it is not logic to have an intersection between 2 main roads and intersection between the 2 main roads and a local road at the same time. So, and this of course depends on the configuration of the network. This is approximately, or this is an approximate network, but in real life, you know the position of the intersection exactly between this road and the local road you have. Okay, so I inserted the first connector, which is like this, and to this one also. Okay, I'm going to add another one from this to this one, and from this to this one. The same thing will happen to each zone, like this. I can open them so I can see all the connectors. I opened it from this icon, so I can see the connectors I've added before. Okay, it is not wrong that you add a connector like this. Okay, it is not wrong, but it is not logic, because in most of the cases we do not have so many roads intersecting at the same point. We are almost done here. Okay, we can add one like this. Okay, so it depends on the configuration, and if this is a real case you have, you will know the configuration of the roads here, but actually in this example I don't know exactly where the local roads we have are intersecting the main network we have, so I assumed some points on the roads which are acting as an intersection between the main road and the local road. Okay, these connectors are not going to be analyzed, but these are just connectors to move the vehicles from the centroid of each zone to the network which we have built earlier. So the next thing we are going to do is calculating the Skim matrix. Our network is now ready and is done. So we are going to calculate the Skim matrix. Okay, in order to generate the Skim matrix, we are going here to the matrices. You can find it here. In some versions, you can find it somewhere here. So I select the matrix here, select add, and choose, for example, I can call it, give it the name Skim, and call it Skim Matrix, and select here it is Skim Matrix. Okay, this is data. Okay, we are going to keep everything else as it is, and select OK. So this is the Skim matrix, which is not generated yet, but it is prepared by the program. We are going here to go to calculate procedure sequence, and select create in here, and choose matrices, and we are going to look for Prt Skim matrix, which is this one. Prt is for passenger car units. The passenger car units we are going to deal with, because in this example we are having our demand matrix in passenger car units, and this is the most simple form to deal with any types of vehicles. We are converting any type of vehicle to the passenger car unit. Okay, so we are going to choose calculate Prt Skim matrix. Prt is for passenger car units, and select OK. And in here we are going to choose in the reference object, this is the car, and in the variant file we are going to check the t-note, which is calculate the t-note because this is the free flow time we are going to deal with and going to be generated. This is the free flow speed. I think this is not required here because we defined already the free flow speed of each link. And you click OK. I don't know if it's selected or not. Okay. Then the one last thing to do is to click the run button, which is this. Sorry, this one. Okay, this the running this green one. Okay, if you need to see your matrix, which is generated now, and to see your matrix, you're just to select your matrices and double click on the Skim Matrix, and you can see your Skim Matrix. It is displayed in this way. For example, from zone number 1 to zone number 1, for sure this time is 0. From zone number 1 to zone number 2, the time is 0.5 minutes. From zone number 1 to zone number 3, it is just 1 minute. For example, from zone number 7 to zone number, for example, 8, it is 0.96 minutes, and so on. Okay, back to our network. Okay, this is the end of part number 2, the second part of the video. The third part will we will know how to make the trip assignment on this network and know each link will have how many vehicles on it in the peak hour. Okay, for the third part here, we're going to perform the trip assignment to this network by knowing this demand matrix. Okay, in the Visum, we're going again to the Visum and choose matrices and create a new matrix. Just add this matrix. This is the demand matrix which we have in Excel. Demand matrix. Okay, and we are going to choose here demand matrix and click OK. Okay, we have the 8 zones. We are going to the Excel. Simply select it all, Control C, go to Visum and click in here, Control V. Okay, so the numbers of the passenger car units are added to the demand matrix. Now we're going to calculate again procedure sequence and we have to before doing the run here we should go to demand and demand data, and from in here we're going to select our matrix, select here demand segments, and from demand segment we are going to look for our newly created matrix in here. We just need the cars, so we're going to choose select here and select matrix by number, and this is the demand matrix which we have created. Okay, so we choose here matrix 3. I think we do not need this at all. Okay. Back again here in the matrix tab, or the procedure sequence, sorry, which we selected from here. We are going to create a Prt assignment. This is again a trip assignment, but using Prt only, which is the passenger cars. Okay, we are going to click OK, and here the reference object. Once again, this is the C car, and we are going to keep it equilibrium assignment. This is the one we are dealing in our syllabus, and make sure that you you close this one. Okay, we are going to close this one, this one, which is the time matrix, because we do not this to be affected. We are going to keep it as it is, as the free flow time, so it is not going to be calculated once again. So we are going to close this one before making our run. And now we are ready, so we are going to make sure that this is one is the only active one, and click run. Then we're going back to our network editor. We are going to see the volumes on each node. The volumes are here, for example, 752 passenger car units per hour. This is 1,250. This one is very bad. This is 3,116. So these are the volumes. We can keep it as it is, or you can make it as a V over C ratio. You can do this by going back to the network and look for links, and from links graphic parameters, and display the bars, and here we need to display the V over C, so we can select an attribute in here and choose the volume capacity ratio, Prt. Okay, we're going to select OK. And select OK again. Okay, so you're going to have now to have the percentage. For example, this is 91%, which is a very bad level of service. We have a good level of service here, which is 19%, because the volume over the capacity is 19%, and so on. You are having a good level of service here, and so on. For sure, you can display it as a decimal, not as a percentage. You can go in here and in labels. Oh, sorry, we just click this, double click on this bar type and go to label, and from this label you can multiply by 0.01. So if you click OK, okay, we do not have decimals here. We're going to go back again, bars, double click on this, and in the labels we are going to have the number of decimals, 3 decimals, for example. Okay, so we are going to have now to have the decimal in decimal form, and according to the codes or the standards, for sure when the V over C is less, this is a better level of service. And you can explore by yourself in the bars. You can change the colors. Sorry, we are going here, and you can the fill style. You can make it also classified. For example, you can add some regions. For example, from 0 to 0.1, this is a color. From 0.1 to 0.2, this is another color. From 0.3 to 0.5, this is another color. And okay, you can change the color as you like here, for example. Okay, if you press OK, so you'll have different colors here according to the number you have, and so on. Okay, that's all for now, and thank you for watching. Please, if you have any inquiries, just leave a comment below the video. I hope this video will be very useful for you.